Now, coming from the network layer, we have the data link layer. The data link layer is in charge of making sure that the data being transferred from one frame to another is not corrupted during transfer. It encapsulates the data packet with the destination and source MAC addresses, Ethernet type, and at the end of the data packet, the file checksum. At the very beginning of this process, before the frame technically starts, a preamble is added that sends a signal to the receiving computer that data is about to get transmitted. The data link layer also does basic error checking. It also makes sure that all the data that got sent is received. Encapsulation is where the data received is surrounded by a header and trailer which completes the frame. First, it puts in the destination MAC. Second, it puts in the source MAC address, the physical address of the computer that sent the information. Next comes the Ethernet type, which is just the protocol that will be used over the network as it travels from point A to B. At the end of the frame, it adds a file checksum so that it can check to see all the data that is received at the other end. The data link layer is the only layer in the OSI model that adds something to the end of the frame. Lastly, it adds a preamble, which, as you know, is not technically part of the Ethernet frame, but is just added so that the receiving computer knows data is about to be received. Here you can see the layout of an Ethernet frame. As you can see, the maximum size of a frame is 1518 bytes. The minimum is 64. The computer needs to know where the data is coming from and if the data received was meant for that computer. It does this by using a MAC address, one for the destination computer and one from the source computer. A MAC address is a series of 12 hex characters, the first half being the block ID, which is unique to the NIC's vendor, the second half being specific to the individual NIC, and based on the manufacture date and model. The MAC address is burned into the hardware, so that it does not change unless the hardware is switched out. Here's an example of a MAC address, in a format I'm sure most of you are familiar with, a command window. The last part of the frame is the FCS, or file check sequence, that allows you to check data received with something similar to a hash. It compares the data using an algorithm called the cyclic redundancy check. In the event that data is not complete, the device registers that the data is not all there, drops the data received, and sends a signal to the device that sent that data saying that some data was lost. Then it waits for the transmitting device to retransmit.